So in this lesson, we're going to finish off graphing our trig functions by looking at cosecant and secant. And these are actually pretty straightforward as long as you remember how to graph sine and cosine. Because remember, cosecant is 1 over sine, so we have a relationship between sine and cosecant. And then secant is 1 over cosine, so we've got a relationship between cosine and secant. So how does knowing cosecant x is 1 over sine x help us graph cosecant x? Well, let's go ahead and graph sine first, and then we can see kind of how the cosecant works out. So if you remember, sine has a period of 2 pi, so if we're going to graph exactly 2 periods, I'm going to go from 0 to 4 pi, and then it has that nice kind of wave shape, starting at 0, 0, going up 1, then hitting 0 again on your x-intercept, down 1, and so on. So let me just go ahead and graph that sine of x. Okay, so I graphed sine of x in kind of that dashed dotted line because we don't actually care about sine of x. But we want to use sine of x to help us figure out cosecant x and what that graph looks like. So remember, what we're doing is we're basically just reversing your fraction. So if you look at 0 here, this 0, 0, if we're doing 1 over sine of x, and remember, if we're thinking about this as a function, y equals sine of x, then, for example, cosecant of 0, oops, I wrote cosine instead of cosecant. For example, if we're going to figure out, okay, what's cosecant of 0, we're going to do 1 over sine of 0. So we're going to look at the y value, so that's 1 over 0, and we like, wait a minute, this is undefined. So when we have an x-intercept and we're trying to do cosecant, we're going to do 1 over y. So when I do cosecant 0, I'm doing 1 over 0, which just doesn't work. That's undefined. So now we create an asymptote. And you'll notice that's going to be exactly the same for any other x-intercept because we're still going to be doing 1 over 0. And we can't ever figure out that value. So we have all these asymptotes where we have an x-intercept from sine. So that's the first key thing to remember. Our x-intercepts of sine x become asymptotes for cosecant x. Okay, so graphing your sine of x will help us find those asymptotes for cosecant x. So then we can draw in those dashed vertical lines. And then to finish off the graph, it's actually super easy. These maximum and minimum values here on each of these humps are going to be points on our cosecant graph. And what we're going to do is we're basically going to draw u's. So we want to flip it, right? Because we're doing the reciprocal 1 over sine x. So instead of having a u going down, we're going to have a u going up, like that, going toward our asymptotes. Same down this way. We're going to have that same point there at the minimum of your y equals sine x. But now we're going to flip it, and our u is going to go downward. And that is how we graph cosecant. So I would encourage you all to graph your sine first to get your x-intercepts, which then become our asymptotes. And then using those maximum values, we're going to create our u's. And we want 2 full periods, so we want 4 completed u's, just like that. So just writing that last bullet point there, we're going to draw a u shape, right, going the opposite direction from the original sine function to create the cosecant graph. And it's going to go up and down forever, so we're going to have those arrows going toward our asymptotes. Okay? So secant of x is basically the exact same thing, but now instead of you starting with y equals sine x, we're going to start with y equals cosine x. So let's go ahead and graph that cosine function first. So I'm going to go ahead and same thing, right? Going from, well, I want 2 full periods, but remember with cosine, let me just start you guys off. We start, instead of at 0, 0, we start here at 0, 1. And because I want 2 full periods, I want 4 lovely completed u's, I'm going to go a little bit past 2 periods for cosine, and you'll see why. And that's because we start here at 0, 1. So let me go ahead and graph my cosine x. If you want to do that too, go ahead and do that and pause. So there's my cosine, and you can see I did go a little bit farther. I did about a quarter more, and that's because I want to get 2 full periods. I want, for secant, I want 4 lovely complete u's. So I want to be able to start and finish with asymptotes. So remember, those x-intercepts become asymptotes. So if I just started there with 0, 1, you'll see how I'm only going to get half of that u. So I'd rather have the completed u. So I wanted to bump it out just an extra quarter. So then I can do 4 lovely completed u's as my 2 periods for cosecant. Oh, excuse me, for secant. Sorry about that. My dog went a little crazy there. So again, I want two full periods, so 4 complete u's to make it a nice graph, a nicer graph to look at. If you did half a u, it's not going to make a difference, but it's just kind of incomplete, so it doesn't always look as nice. So just like before, our x-intercepts of cosine now become the asymptotes of secant. And then just like before, once we get our maximum minimum values, we're going to go ahead and draw u's. So I'm ignoring that 0, 1 because I'm going to use these asymptotes to create my 4 u's. So I'm going to start here and have a u going down. Then from 2 pi, have a u going up. 3 pi, have a u going down. And then 4 pi, have a u going up. And there's my cosecant. Or excuse me, my y equals secant x. I keep thinking cosine, cosecant, but again, y equals secant x here. So it looks very similar to cosecant. It's just where the u's are different, right? Where the asymptotes are different because sine and cosine are different. And that's it. So if we move on to our transformations, same deal. Draw the transformed sine or cosine function first, and then x-intercepts become asymptotes. Draw u's for maximum minimum. So that's always going to be the same method. All right, so if we take a look at example 3, we're going to graph g of x equals 1/2 secant of 1/2 x, identify the period and the asymptotes. So like I said before, don't worry about the secant for now. Just remember secant corresponds to cosine. So let's go ahead and graph, let's call this h of x equals 1/2 of cosine of 1/2 x. So then I can remember back from when we talked about graphing sine and cosine, how the amplitude, how the period changes to graph this transformed cosine function. So remember, my amplitude is that number in front, which is 1/2. So that tells me my maximum will get up to positive 1/2. My minimum will go down to negative 1/2, right? And then my period is 2 pi divided by the absolute value of b, which is 1/2 here. So 2 pi divided by 1/2 gives me 4 pi. And then I can create my cosine function. So remember, we want 2 full periods, so we want to go up to a little past 8 pi. So make sure you space out your function well. I'm going to go ahead and break it down by pi over 2. So let me go ahead and draw in my axes. All right, so now we want to go ahead and draw that corresponding transformed cosine function. So since my amplitude is 1/2, I'm going to go 0, positive 1/2. Right, there's no phase shift, so I'm not shifting anything left or right. There's no vertical shift, I'm not going up or down, so I'm still using 0 as kind of that midline. And then I have my x-intercept at pi, and I can just go down to negative 1/2. And you can see I'm still following the same old cosine pattern here. And then just like I showed you before, if we're doing cosine, because I do want to hit the x-axis 5 times to get 4 complete u's, I'm going to go ahead and go an extra quarter and stop there at 9 pi. All right, so there's my cosine function, and you can draw in the curve if you'd like, but really what matters are just the points. So I'll just draw on that first curve. You don't actually have to draw the curve because what I care about is secant. So every x-intercept becomes a vertical asymptote. So that's what I'm using those x-intercepts for, is to find that vertical asymptote. And then those high and low points are going to be where my u's begin. So I'm going to go ahead and draw a u going down at 2 pi, a u going up at 4 pi, and so on. So you can see how you don't actually have to draw the curve for cosine, but if it helps you visualize, go for it. And there is the transform function, 1/2 secant of 1/2 x. So if we look at the next example, transforming cosecant, same deal. First, figure out the transform sine function, and then find your asymptotes, find your u's. So in this case, we'll notice, right, we're graphing negative cosecant x. So let's call this h of x equals negative sine of x. So there's no change in the amplitude. There's no change in the period, which is kind of nice. So my amplitude is 1, so then I know my maximum is going to be positive 1. My minimum is negative 1. My period is the same old 2 pi because it's not changing. But what does that negative do? So remember, that negative tells us there is a reflection across the x-axis because there's a vertical flip. So what does that do? So remember, if we started with y equals sine x, it looks like this, right? Then if we flip it, what happens is rather than going up first, we're going to go down, so it becomes that kind of mirror image. So that's what we want to do in the graph. I only have to get up to 4 pi, so let me go ahead and break down my graph like I normally would. So that x-axis, I can go by increments of pi over 4. All right, and then you can see how, oops, I wrote 8 pi instead of 4 pi, my bad. And then I just went up and down by 1/2 to get 1 and negative 1. So the sine function, remember, starts at 0, 0, and then it normally goes up 1, 0, down 1, but now we're reflecting it, so we're going to start by going down 1, hit 0, then go up 1, right? So that's what the reflection does, is we just flipped our original y's around. And then again, you can draw the curve if you'd like, or just use these points because we are using the x-intercepts to find the asymptotes. And again, no phase shift, no vertical shift, so that's why I'm not shifting anything left, right, up, or down, so 0 is still that midline. And then those points up and down, right, tell me where the u's go. And this is my transformed cosecant function. All right, so cosecant, secant, very tied to sine and cosine, so as long as you're very strong with sine and cosine, these transformations should hopefully be pretty straightforward. Just remember, x-intercepts become asymptotes, and then we draw u's from the maximum minimums. We didn't do any shifts, phase shifts, or vertical shifts here, but remember, just like with sine and cosine, when you shift up and down, that 0, that midline, is what goes up and down. If we're shifting the phase shift left or right, we're just moving the x values, either, pi over 4 to the left, pi over 6 to the right, whatever that is. Okay, so that is cosecant, secant, and that wraps up all of our trig functions that we had to graph. If you have any questions, please let me know.